In the network shown, the switch is closed at t is equal to 0 plus with capacitor is uncharged. Initially, the capacitor is uncharged. Find the value of I di by dt d²i by dt square at t is equal to 0 plus. So I'll repeat once again. The switch is closed at t is equal to 0 plus. This is t is equal to minus infinity and this is t is equal to plus infinity. This period is called as before switching. This is just after switching. This is for t greater than 0. Okay. Before switching, just after switching, greater than 0. Now before switching, the switch is closed at, if they give arrow mark like this, at t is equal to 0 only, the switch is closed. At t is equal to 0 only, switch is closed. Before that, the switch is open. When the switch is open, no current is flowing. So IL of 0 minus is 0. Because initially the switch is open, no. At t is equal to 0 plus only, the switch is closed. So before switch is open, no current is flowing. So there is no chance that your capacitor is going to charge. Capacitor voltage is also 0 volts. Okay. Because switch is closed at t is equal to 0 only. For this period, for t is equal to 0 minus infinity to t 0 minus, the switch is open, no current is flowing in the circuit. So that's why initial current in the circuit is 0 and initial voltage across the capacitor is also 0. Now the switch is closed at t is equal to 0 plus. At t is equal to 0 plus, the switch is closed. The switch is closed at t is equal to 0 plus. Now what happens? Okay. What happens to this? Now this is 0 volts means short circuit. 0 volts means short circuit. Okay. And it acts as a short circuit. Capacitor acts as short circuit now. So this I told you to remember the diagram, important diagram. Capacitor just after switching acts as capacitor just after switching acts as short circuit. Just after switching acts as short circuit. This one is short circuit. For t is equal to infinity, that means steady state is reached, then only it acts as open circuit. I told you to remember battery. Whenever you put a plug into your battery, it will start charging. That is possibly only if the circuit is closed. That means that element should act as a short circuit so that current will flow. Open circuit means no current flows. So capacitor acts, and you see, remember voltage across capacitor, it is 1 by C integral of I of t dt. For inductor, L into di by dt. For capacitor, 1 by C integral of I of t. For resistor, V is equal to I of R into I of t. Now, at t is equal to 0 plus, capacitor acts as short circuit. For t is equal to 0 plus, just after switching, capacitor acts as short. Here it acts as short circuit. Switch is closed at t is equal to just after switching. 0 plus means just after switching. Please remember, this is only just after switching, at that instant. Just after switching, capacitor acts as short circuit. Now the circuit is closed, RC. Switch is closed, resistance remains resistance only. Capacitor acts as short circuit and there is a closed path. Now I of 0 plus is not 0 because there is a closed path, and in this path we have V and R. So if V and R is there, easily we can find current. V is equal to I is equal to V by R. V is 100, R is 1000. So 100 divided by 1000 is 0.1. So just after switching also, capacitor voltage, see I told no, your battery is 0% and you are going to plug into your power supply and switch on. Just after switching, instant, when you press the button, power button on, immediately if you check the voltage of your battery, still it is 0% only. So capacitor voltage just after switching is 0 volts only. But current in this circuit, it acts as a short circuit. No, what is the current flowing in this circuit is, in this circuit voltage is V, R is 1000. So V by R, V by R, V is 100, R is 1000. So 100 divided by 1000 is 0.1 amps. That is I of 0 plus. In the inductor circuit, we have L di by dt voltage. So immediately L di by dt or di by dt you can find out. For a capacitor, for t greater than 0, you have to write instantaneous capacitor voltage. There is integral differential equations you have to write. So consider this is minus, plus, plus, minus, plus, minus. Now if I write KVL for this, minus V, okay, minus, minus V means that is a minus 1000, minus 100, minus 100, plus or 1000 into I of t. In general, for t greater than 0, don't write plus and all. In general, it is I of t plus what is the current in inductor is 1 by C integral I of t dt is equal to 0. Okay. Throughout, if you multiply by negative, you'll get this one only. Okay. Minus. So this one, if I multiply throughout with my negative, we'll get plus. This is minus. This is minus. So I told no different author uses different notation. We can. So this is voltage. This is a voltage across resistance is 1000 into I of t. Voltage across capacitance. This one is nothing but voltage across capacitor. VC of t. Voltage across capacitor. I want to find di by dt. What is the question? Find I of t, di of t, and d square I of t. I di by dt, d square I by dt square. But here there is no di by dt. There is integral is there. For in the previous problem, L di by dt was there, so easily we found out. For capacitor, you don't get to di by dt immediately. You have to differentiate. So if I differentiate this equation number 1, if I differentiate this equation, differentiation of 100 is a constant. 100 is a constant. So differentiation of 100 is 0. Constant, no, differentiation of constant is 0. And 1000 di by dt 0 plus di by dt plus this 1 by 10 power minus 6, 1 by c, no, 1 by c value is micro. If you see the calculator, micro means 10 power minus 6. So if I bring it to numerator, it becomes 10 power plus 6, and differentiation and integration get cancelled. We remain with I only. This is I of t actually. We remain with I of t is equal to 0. Okay, I will repeat once again. I have to differentiate this. Now the differentiation of 100 is constant, it is a 0, plus 1000 into di. Already I of t is there. So if you differentiate di by dt of t plus this is 1 by c. This is all micro. If you bring it to numerator, minus 6 becomes plus 6. 10 power 6. Differentiation integration get cancelled. We left with I of t. Okay. So di by dt is equal to di by dt of plus is equal to this 10 power 6. You bring it to right side. This you bring it to right side. It becomes minus 10 power 6. And this is equal to, I will write one more extra step. Di by it is di by dt 0 plus I will bring this is 10 power 6, and di by dt is equal to minus 10 power 6. This will become numerator now here. So this is, and here I is there, 10 power 6 I, 10 power 6 I of t. Okay, and di by dt equal to 100 10 power 6 1000 I of t, and t is equal to 0 plus di by dt of 0 plus is equal to 10 power 6 by 1000 I of t 0 plus. Now I have to substitute I of 0 plus from this previous answer. What is the previous answer? I of 0 plus, I of 0 plus is zero point 0.1. I of 0 plus is zero point 0.1, that is V by R. You substitute 0.1 here. So 10 power 6 by 1000 into 0.1. So calculate using calculator, you will get. Okay, I can do here. Then you write, okay, power 6. I'll do this one like this. 10 power 6 divided by 1000. This minus is I'm not taken here. You can write initial also. This answer multiplied by 0.1. It is minus 100 ampere per second. So the reason is I by T. I value is current. Current unit is ampere. dt delta T is time. So ampere per second. This minus will come because this plus 6, 10 power 6. If you bring it to right side, becomes minus. So this answer is one answer we got. One more we have to find out d²i by dt square. To find the d²i by dt square, differentiate this equation once again. Differentiate this equation or this equation once again. 1000 already you can differentiate this also, or you can differentiate this also. d²i by dt square is equal to, this full thing is constant. 10 power 6 by 1000 is a constant, and I of 0 plus, if I differentiate, you'll get this is also t. Here also will get t, and substitute at t is equal to 0 plus d²i of dt square at t is equal to 0 plus 10 power 6 by 1000. This value will get di by dt of 0 plus. Di by dt of 0 plus, again you have to get it from previous. So it is equal to minus 100. Substitute here for this value. Substitute minus 100. This minus, and again one more minus. Minus into minus, it becomes plus. Okay, minus into minus becomes plus. So this is 10 power 6. Again here 10 power 2 is there. So 10 power 8. 10 power 8 minus 10 power 3 is 10 power 5. So minus into minus is plus. So answer is 10 power 5 ampere per second square you have to write, because it is d square, t square. Don't write ampere square. Del square I you have to write ampere only. Only for time t square you have to write second square. Similarly, same problem here in general form. Okay, for the circuit, the switch is closed at t is equal to 0. Find di of 0 plus, d square di of 0 plus, and d square of 0 plus for t greater than 0. Okay, you can see there is the same problem. Instead of values, you have to consider R and C as it is. So you're going to get I of 0 plus is what? V by R. There also we got 100 by 1000. It is zero point 0.1 amps we got. V by R you are going to get. Capacitor acts as short circuit. V by current is equal to V by R. Similarly, for t greater than 0, right? Integral differential equals applied voltage is equal to drop across R. R into I of t. Voltage of capacitor is 1 by s integral of I of t dt. Okay. And there is no di by dt. So you have to differentiate this equation once again. Differentiate with respect to time once again. V is a constant. V is a constant. So differentiation of voltage is 0. R into di by dt 1 by c. Differentiation integration it cancel. So we'll get di by dt R into di by dt plus 1 by c into I of t. At t is equal to 0 plus, at t is equal to 0 plus this 1 by c, now if you bring it to right side, it becomes minus 1 by c I of 0, and this r also you have to divide. Here r will be there, that also you have to divide by r, means it will come here. So expression for di by dt, general expression, it is general expression for di by dt is minus v by r square into c. So you substitute in our problem 100 by 1000 square into c micro. You will get that much into ampere per second square. You will get minus 100 here. And to get d²i by dt square, once again you have to differentiate this equation. Once again, if you differentiate this equation only, then you will get d²i by dt square is equal to 1 by rc. 1 by rc di by dt, di by dt at 0 plus. Di by dt's value is this, di by dt at 0 plus value is v by minus r squared by c, and again it is multiplied with rc. So it becomes v squared by r cube into c squared. This is plus now. It is becomes plus now. Same values. It is general equation, and this is with some values. Okay. Thank you.